Hi, kids. This tutorial is going to be a crash course in Bohr models one more time. I'm going to post it on Classroom so that you have it available. And for those of you who need to review it, you can. I'm doing this because while some of you already are acing any quiz I give you on Bohr models, some of you are still not getting the concepts. And this will be something that you can look at and watch it over and over and over again until you figure it out. By the end of the video, however, it's going to go into new material that everybody should be watching, and that has to do with the valence electrons and ionization of atoms. So let's go to the next slide. I'm going to give you an example. We're going to go ahead and we're going to try to make a Bohr model for the element that has atomic number 4. I look at the periodic table and I look for the element that has a 4 above it, and I know that it's beryllium. Okay, and there it is there on the left-hand side. You can see it, and it's got atomic number 4. So that I use that to identify the element, but also I know right away now that I'm talking about an element that has 4 protons in its nucleus. So I'm going to go ahead and put those in there. Okay, because the atomic number tells me that. That's easy, easy, easy. Okay. I also know, though, that this atom is going to have 4 electrons. This is very easy. The atomic number tells you the name of the element, it tells you the number of protons, and it tells you the number of electrons. With electrons, though, some of you really need to review this at home and spend some time going over this, because you're not remembering where to put the electrons necessarily. You know they go outside of the nucleus, but you're messing up with your placement of them. When we're dealing with Bohr models, we have to follow certain rules, and we have to remember that first shell that surrounds the nucleus, that can have up to and no more than 2 electrons. After that, you go to the second shell, and you can fit up to but no more than 8 electrons on the second shell. And then, if we're dealing with Bohr models, you have to then move on to the third level, where you can put up to 8. And once you put 8 on the third level, you now have to move out to the 4th level. And remember, I'm telling you that there's more to this story. Bohr models can only take us so far in chemistry. In fact, we can only use Bohr models for the first 20 elements of the periodic table. Once you get beyond atomic number 20, the Bohr model does not work accurately, and you have to learn new information about electrons. All right, so here is our complete diagram for beryllium. I have 2 of its 4 electrons on the first shell, and then the remaining 2 electrons are on that second shell. Okay, all right. Now, what about the neutrons? Well, let's say I was dealing with mass number 9. You might remember that a lot of elements can have more than one mass. For instance, there is beryllium 9. I believe there's beryllium 8. I think. Anyway, beryllium 9 is the most common isotope for beryllium. And that means I can go ahead and I can use that 9, because that's going to help me figure out how many neutrons this atom has. Because it's simple math. The 9 tells me that there has to be 9 particles, 9 subatomic particles that are in this nucleus. But I already know that 4 of them are protons. So how many must be neutrons? Well, that's easy math. 9 minus 4 equals 5. So I know that I have 5 neutrons, and I'm going to throw them in there, and there I go. And now I'm complete. And if I was a student, I'd be getting an A+, because I did it all accurately. Okay, so now we have sodium and fluorine. We're going to move on. Now this is the new topic we're going to get into, right? And in order to understand this new topic, you have to know how to do Bohr models. That's why I was pushing you really hard to learn that material, because until you understand Bohr models, you can't begin to understand this next topic. You have to make sure you get yourself there. So practice, practice, practice. Okay, sodium and fluorine. Sodium has atomic number 11. Fluorine has atomic number 9. Bam. With that information, I know that sodium has 11 protons in the nucleus. And remember, it's very acceptable to do it this way. You can use numbers. And fluorine has 9 protons. Easy, easy, easy. I also know that sodium has 11 electrons and fluorine has 9 electrons. Easy, easy, easy. The next part's a little tougher. I have to do my homework. If I'm a student, I have to make sure I learn these rules. And that is that I have to put two of sodium's electrons on the first shell, two of fluorine's electrons on its first shell, and then I have to move on to the second shell. So with sodium, I clearly have 8 electrons that go on the second shell, and I still have one left down here that I haven't played with yet. With fluorine, however, I'm all done. Look, it only had 9 electrons total, so I don't even need to go past the second shell. I put 2 on the first shell, and I put 7 on the second shell, and fluorine is done. Well, I'm not worrying about neutrons today, but other than that, fluorine is done. With sodium, I'm not done yet because I've just filled the second shell. I can't get any more than 8. I can't put any more than 8 electrons in that second shell. So now I know I have to move on to the third shell, and that's what I'm going to do. Great. However, dun, 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 we have this thing called the octet rule. You might remember this, and it's essentially saying this, okay? Atoms do not like having incomplete outer shells. Whatever their outer shell is, and for one atom, that could be the first shell. For another atom, that could be the fourth shell. It doesn't matter. What matters is atoms do not like to have incomplete outer shells, and they will do what it takes to achieve that. They will do what it takes to make it so that they have an outer shell that is completely filled with electrons. Now, don't get confused here. I'm bringing neon into the mix because I want you to take a look at neon for a minute. Neon has atomic number 10. So it has 10 protons. Great. It's got 10 electrons. Awesome. Where do those electrons go? Well, 2 go in the first shell and 8 go in the second shell, right? And that's it. We're done. And neon is like, awesome. I'm happy. I have a complete outer shell. My second shell is filled with 8 electrons. Neon is a very content atom. And I don't want to get too deep into this yet, but it's for this reason. The fact that neon has an outer shell that is completely filled with electrons, that is why neon hardly ever, like neon will not react naturally with other elements. It stands on its own. It's known as a noble gas. It is not reactive with other elements. Scientists can do like weird, crazy things with these gases to make them kind of react, but that's not for us to worry about. In the natural world, neon is an inert gas. It does not react with other things. Now, sodium and fluorine are I'm kind of going to give these atoms personalities right now. Think of it like this. Sodium and fluorine are very jealous of neon. They want to be like neon. They want to have an outer shell that is complete, like neon. Right now, sodium is not. Sodium has a third shell that has just 1 electron in it. So sodium is not, quote unquote, happy right now. Fluorine has 7 in its second shell. So it also is, quote unquote, not very happy right now. But watch what these atoms will do. I'm going to go back and forth for a minute. Take a look at what happened there. Look what sodium does with its 1 pesky little electron on the third shell. It goes ahead and it sheds and donates that electron to fluorine. So the electron jumped from sodium's third shell and went over and helped to fill fluorine's second shell. Now, both of these atoms are happy in a way. They're like neon. They both have outer shells that are complete. And when this happens, we say they are ions. In this case, sodium, let's look at sodium. I want you to look at the atom of sodium right now as I'm saying this. Sodium has 11 protons, but now it only has 10 electrons. So that means it has 11 positive charges in its nucleus, but only 10 negative charges in its outer shells. That means it's got a +1 charge. The atom took on a +1 charge. That means it is now a positively charged ion, and we actually call positively charged ions cations, cations. Fluorine accepted the electron, and so now fluorine has 10 electrons in its shells, which is one more than the protons that it has inside its nucleus. So fluorine will take on the opposite. Fluorine will take on a negative charge by 1. It becomes a 1 negative charge. And when an atom is ionized negatively, we call it an anion, A-N-I-O-N, anion. So in this case, I want you to understand sodium is a positive ion now, and fluorine is a negative ion now. All right, hopefully this helped you a little bit. I'm probably going to make a couple of more videos like this over the next couple of weeks for you, and you should be watching them as many times as you need at your own pace so that you learn this information well and get an A on that next quiz. Thank you. Bye-bye.